So we have so far discussed that electric field into area, here more of it like E dot dA is equal to electric field into area is equal to electric flux. Let us the next thing in lines of force, we have studied that the number of lines of force from 1 coulomb charge in vacuum will be 1 by epsilon naught lines of force, and in q coulomb charge, number of lines of force originating from q coulomb charge will be q by epsilon naught. One is electric flux's total number of lines of force. Electric flux is also equal to E dot dA, electric field intensity or electric field into area. So we are going to combine these two and apply for a closed surface, that is called Gauss law for electrostatics. One simple example we'll take. So this is a closed surface, it's a pouch, it's a closed surface. So I'm going to open this pouch and take 1 coulomb of charge and put this inside the pouch and close it. All the lines of force will come out of this pouch, right? So all the lines of force will come out of this pouch. The one thing, generally there are two kinds of fluxes, flux in and flux out, positive and negative. Positive in the sense, if in a school 200 students are passing out and 300 students are joining. 200 students who are passing out is called outflux. 300 students who are joining is influx. The net flux is 300 in, 200 out, then 100 is the net flux. So we need to assign signs to that. Usually the flux or the area, the direction of the area is going to define the direction of the electric field, right? Suppose if it is a closed area, we usually attach the direction perpendicular to the or outward the surface is taken to be positive. Only then if there is a charge q over here, that charge will also have the electric field in the same direction, then you will get a positive value. So the first thing is, if the lines of force are coming through and out of the surface, then the flux is positive. If it is going into it, it is going to be negative. Then suppose I've just put 1 coulomb of charge, then out of 1 coulomb of charge, 1 by epsilon naught lines of force you can draw in vacuum. All those lines of force will come out of this pouch, then flux through this pouch. A pouch here represents a closed surface. So the flux through this pouch is 1 by epsilon naught. Instead, if I put 2 coulombs of charge inside, the number of lines of force coming out of this pouch will be 2 by epsilon naught. Then if I put 3 coulombs of charge and then minus 2 coulombs of charge, then out of 3 coulombs of charge, 3 by epsilon naught lines of force will come out, but 2 by epsilon naught lines of force will go in, because that's a negative charge, all the lines of force will go in. Then the net flux will be 3 by epsilon naught outwards, 2 by epsilon naught inwards, then the net flux will be 1 by epsilon naught outwards. So from this, what do you understand? If there is a closed surface, if you put 1 coulomb of charge, flux through the closed surface will be 1 by epsilon naught. If you put q coulomb of charge, flux through the surface will be q by epsilon naught. But if this q is the net charge, because if I put plus 1 coulomb, plus 7 coulomb, minus 2 coulomb, here q represents the net charge is 7 plus 1 8, 8 minus 2 6, because 8 by epsilon naught lines of force will go out and 2 by epsilon naught lines of force will come in, then the net flux will be 6 by epsilon naught. So if the total charge, the net charge inside the surface or the net charge enclosed by the surface is q, means flux through this closed surface, only for this closed surface, the flux through this closed surface is q by epsilon naught. So electric flux through a closed surface, So in order to show that it is a closed surface, you are going to integrate this. Suppose if it is E dot dA, the total flux will be integral E dot dA. Closed surface is E dot dA or ds, sometimes they are referred to, is equal to the total charge enclosed by the surface by epsilon naught. This is called Gauss law for electrostatics. Gauss law for electrostatics is applicable for a closed surface. Then the total flux through a closed surface is defined as, the total flux through a closed surface is defined as 1 by epsilon naught times the net charge enclosed by the surface. See, the thing is, based on this, we are going to find out what, once we found out electric field due to a straight rod, electric field due to a disc, and then through an infinitely large sheet, etc. All those things can be very simply be done using this Gauss law for electrostatics. In Gauss law for electrostatics, and since it is applicable only for closed surface, depending on the problem, you will have to assume a hypothetical closed surface to apply Gauss law, because not this closed surface is hypothetical. It's not necessary that it has to be present. Suppose you take a straight wire, you would like to find out electric field at a point, you can apply Gauss law. In order to apply Gauss law, you are supposed to assume a hypothetical closed surface. A hypothetical closed surface to apply Gauss law that you assume is called a Gaussian surface. This Gaussian surface, to apply Gauss law that we imagine, may not be real, it is imaginary. So you keep that thing in mind. So with one thing we will close our discussion. Flux unit. The unit of electric flux is the unit of electric field into unit of area. Electric field is Newton per Coulomb. Area is meter square. The unit of electric field is Newton meter square per Coulomb. The unit of electric flux is Newton meter square per Coulomb. Know that electric flux is a scalar, whereas electric field and area are vector, and integral around the closed surface E dot dA is equal to Q enclosed by epsilon naught. This works only when the surface is closed. So the direction perpendicular to the surface and outward is taken to be the direction of the area. The direction perpendicular to the surface and outward is taken to be the direction of the area. See, through 1 coulomb of charge, you can draw 1 by epsilon naught lines. Through Q coulomb of charge, 2 by epsilon naught lines. Q coulomb of charge, Q by epsilon naught lines. Then the other thing about Gauss law is, see, you have written closed surface, right? Flux through closed surface depends only on charge enclosed by the surface by epsilon naught. The mystery thing, two things. One is, it does not depend on size or shape of the closed surface. You see, there is no part in the Gauss law. Flux through a closed surface depends only on Q and epsilon naught. Charge enclosed and epsilon naught. It does not depend on the shape. Let us get one example how this works. Suppose we just need to prove it, right? Suppose there is a charge Q, and at distance r, assume a Gaussian surface. Gaussian surface is an imaginary closed surface that you assume to apply Gauss law. This point, all the points from the charge Q, all these points are equidistant. Since the distances are equal, electric field at all points are equal. Electric field due to a point charge at a distance r is what? Electric field is equal to 1 by 4 pi epsilon naught into Q by r square. Since at r distance, at all points electric field are constant, and this surface is a spherical surface. What is the area of the spherical surface? Area of a spherical surface is 4 pi r square. Then the flux through this closed surface is electric field into area. Since electric field at all points are equal, uniform electric field, it is simply E into A. Into A is 4 pi r square. R square and R square will be cancelled. 4 pi and 4 pi will be cancelled. What you are left with? Q by epsilon naught. So what about at a distance 2r? At a distance 2r, if you assume one more closed surface, electric field at distance, electric flux through this bigger sphere is equal to 1 by 4 pi epsilon naught into q by, it is at distance 2r. So it is 2r whole square will be 4r square into area of this spherical surface. This radius is 2r, then the area will be 4 pi into 2r whole square, which is 4r square. 4 pi, 4r square, 4r square. Still you get what? Q is phi is equal to q by epsilon naught. Whether you assume a smaller sphere or a larger sphere, the electric flux through a closed surface is independent or size or shape of the surface, and second thing, it does not depend on the charges outside the surface, charges that lie outside the surface. Because if there is a closed surface over here, if there is a charge here, from this charge, if some 10 number of lines of force pass through this area, it will come out of this, then influx will be equal to outflux, so that will be cancelled. So charges outside the closed surface will not contribute towards flux through the closed surface, and flux through the closed surface does not depend on the size or shape of the surface.